Alright, so let's take a look at how to set up the views for prepared version 4. This should also work in earlier versions. I think version 3 had the same facilities. I'm going to be doing this using the view groups feature of prepared. We're going to look at that in a moderate level of detail, and before we do that we just need to look at the landscape really, if you like. I'm using a triple monitor setup here, so that's, I'm going to be addressing that specifically, but it will generalize to other setups. Now this is traditionally done in flight sims using NVIDIA Surround or iFinity if you're using a ATI card, but that's going to get us into trouble. That won't work. If you notice, my screens are not in a line, they're staggered, so the central screen is higher than the two outer screens. Now to do that you need a facility for operating with 3 separate independent views. There was no clean way to do that in FSX. You could sort of fake it if you used something like Opus FSI, but even that was very cumbersome, and I think I'm right to say you had to, every time you started the sim, you had to manually load the views, even if the positions of the windows were remembered. Anyway, that's far too much detail. Now coming back to the the basic ground rules for what we're trying to do here. Obviously I'm using a home cockpit setup with large screens, and in case I need to make it clear, the ultimate goal for me is to get a life-sized, at least approximately life-sized display, and this ensures that we have the correct proportions and in terms of the size of things that I see in the virtual cockpit. I do use the virtual cockpit and out of the windscreen, but also collateral to that, it means that the speeds are all in proportion to how they would be in the real world, and that's very important for judging approach speeds, control inputs and so on. I mean, if you're going to try and fly this realistically, that's an important factor. Now I accept that not everybody's going to have large screens, and perhaps the goal of actual size is not going to be a universal goal, but that's what we're aiming for today, and some of what I say will depend on that. Now everything we do is going to be done with reference to fields of view. So that's the horizontal field of view, which is an angle. If you like, it's the angle, if you sit looking at the screen, it's the angle. If you drew a line from the extreme right and left of the display that meets at your eyes, it's the angle at which those two lines would meet. That's basically the field of view, and there's an equivalent in the vertical direction. And most of what we're going to do makes reference to those two angles. Now to set up a actual size display, which is, as I say, what I'm trying to do, there's a point at which we need to match those actual angles with the angles that we ask the simulator to display. So one thing that's important going into this is to know precisely, or as precisely as possible, what those angles actually are. So we need to measure them. Well, we can calculate them. I'll say a little bit about the calculations later. If you've seen my older videos on setting up the views, those are the 3 videos entitled something like wide view, aspect and zoom. I did the calculations in there, and but we can measure the angles, and I'll just show you briefly how I've done that. I hope we set up to do, yeah. Now to measure that simply, if you imagine, if you're sitting in the cockpit in the position where you'd be flying the aircraft from, and if you imagine a piece of string going from that edge to your eye, or to the bridge of your nose if you like, and a piece of string going from that side to the bridge of your nose, and then you want to measure the angle between those two pieces of string. So that's exactly what we're going to do. If you just get yourself a long piece of string with like a knot on the end, or a piece of sticky tape to attach it there, I'm going to use this measuring tape, which conveniently has got, it's about the right length, and it's got metal bits on the end, which mean I can just actually slot it between the 2 monitors at each end. And then if you pull this taut, I mean, this is just conveniently, this is the right length, because it pretty much converges exactly where my eye point would be. And if you can see that, what I want to do is measure this angle here, and the simplest way to do that is to use a protractor. This is a aviation protractor, and I'm going to need my glasses to see this. Pull that taut. I mean, there's obviously a degree of approximation in this. We're not going to get a great accuracy, and it's basically coming out very close to 50 degrees. So we have that horizontal field of view measured empirically, and I've recorded that as 50 degrees. Now we could do the same to measure the vertical field of view. You can calculate that from the horizontal field of view. I'm going to have more to say on that as well later, because we need to do that correctly. But you can measure it, and I have measured it, and it's actually pretty much 28 degrees in the vertical direction. So those are numbers that we'll come back to in a little while. So the first thing we'll do is we're going to have a look at the monitor setup just in Windows. There's two ways you can look at this. If you right click on the desktop and look at screen resolution, you'll be familiar with this. You get the layout of the monitors. So I've got 3 monitors with the desktop extended across them in this staggered configuration. I've also got a 4th monitor, which is a small monitor, the one I run my GPS on. I'm not going to use this screen because you can get an equivalent display in NVIDIA control panel, and if we go to set up multiple displays, and this is where I use it. It's, you know, you can customize your desktop using either of those 2 displays really. Just to show you the setup of this, well actually before we do that, if you wanted to set up surround, you'd go to this configure surround PhysX, and there's a wizard basically. If you click the span display, I'm not going to do this because it'll mess up my displays, but if you click that button on, it then launches a wizard and you basically get to set up the surround. But as I say, we're not going to do that because we can't do the staggered display. If we go back to set up multiple displays, you can see I've set up this stagger to represent the physical layout of the screens. Now you have to do that because if you didn't do that, then when you move across between the monitors, they wouldn't line up, obviously. I mean, if you think about that. So what I've had to do is I've had to stagger these so that the monitors line up, and you just do that by grabbing hold of one of these and moving it up and down. Now the problem is it wants to snap to particular positions. I have found if you overlap those and drag up and down carefully, you can get more precise control. And so when you have that set up, basically this desktop acts in a natural sort of manner. So that's all we need to see from the Windows point of view. What we'll do now is we'll go into Prepared and we'll have a look at how to do the setup in there. Alright, here we are in Prepared, and we're just going to take a look at that setup. Got the track IR active as well. I'm going to just pause that for a little while. You can see we've got 3 independent views here. We've got the window furniture visible, so we've got a border and a title bar on each window. We can get rid of that if we do Alt Enter, go to full screen mode. We've basically got the same 3 windows but just without the edges. Now I'm using the EasyCA camera view at the moment. For the purposes of clarity, I'm just going to make sure that's not active. We're going to change the view to be the standard virtual cockpit. So first thing we're going to do is we're going to look at where we set this stuff up. Go to the Views menu and View Group Management, and we get a not particularly intuitive setup display. I'm going to look at there's two kind of separate areas to this setup. The first thing is this section on the left. If I collapse you, the one called Displays. We're only going to take a very brief look at this. This essentially describes the hardware setup that you've got. I've got a GTX 1070 with 4 monitors plugged in. That's the 3 main monitors spanning the forward view, or it's a virtual cockpit view, and the 4th display is the small one that I run the GPS on. Now all you need to know about these is that they're connected. There's 4 of them, and they're numbered sequentially 0 to 3. We're not going to do any more setup with that, so we'll put that away for now. The thing we're interested in is this View Groups section. Now when you first come in here, there'll be one of these set up, and it's called Autofill Desktop. These are the ones, just things I've been playing with. The one labelled Center Up Triple Display is the one that is active at the moment, and it's the one that I fly successfully with. The other ones are just experiments, so in fact there's one called experiment. We've got one called triple screen, super wide, 3 screen. If I just cancel out this for the moment, the way you select between those view groups is if you right click on the main display and select view groups, you'll see that each of those groups that we've just touched on is selectable from that list. So if I choose, for example, triple screen, which is the one I've been messing about with, and there is, now that one I didn't finish with that, it's not completely correctly set up. You'll see if you look at the join between the centre and the rightmost monitor, the bezel management isn't set up, for example. The zoom is very exaggerated there as well. But that's how you select between them. If I reselect the centre up triple display, it's my active display, that comes back. So let's go back into there, views, view group management. What we're going to do is we're going to create a new one of these from scratch, just for the purposes of this demonstration. And I'm running out of unique names here, so we're going to if I click on there, click add, we've got it, it's view group 7, so if I click on that to select it, I can, first thing I'm going to do is just give it a name. So what should we call this? Let's call this video demo triple screen. It's a cumbersome name, but it's just to distinguish it from these other experiments that I've done. So we've done that. Now let's look at the rest of what we can see in this setup. This is not the most intuitive of dialogues. In fact, the first thing I'll do is, if I just briefly go to the internet, and if we do a search for prepared view groups, we should find the SDK page. This is where the dialogue we've just looked at is documented. Now, although this looks complicated and detailed, in practice it's a little bit sketchy. Well, it's very sketchy, and it makes a lot of assumptions about what you already know, and it's not sufficient to really describe how to set up that view, at least in my experience, but it's there for you to refer to, and it's easy to find. So coming back here, the first thing we see on this display is a thing called allow zoom yes or no. Now, just before we move on, I'm going to say something about zoom. What we're about to do fundamentally in this setup is we're going to instruct P3D very precisely about how much of the virtual world, in terms of the field of view, both horizontally and vertically, we want it to display across each of our monitors. The problem with that is, logically, it fundamentally clashes with the idea of a display that can be zoomed in and out. So what you need to know is, from this point on, what we set up in this screen is instructing P3D to display a fixed horizontal and vertical field of view, and we will see that when the zoom factor is set to 1.0. Technically we can then zoom the display in and out, and the field of view in the virtual world that's displayed across our monitors will then vary. Having said that, there is a flag at the top of this setup which says allow zoom yes no. Now logically, in my mind, if you set that to no, the display will then remain fixed and non-zoomable once you've activated it. Now the problem with this is I found it doesn't seem to work consistently. Sometimes when you click that, it does indeed lock the zoom and you can't zoom in and out when the display is active, when the view group is active, but sometimes that doesn't seem to be the case. Sometimes when that is selected to yes and the display should be zoomable, it indeed is zoomable, but other times it appears that the zoom is locked, and so that's an inconsistency which may be something about my lack of understanding of what's going on here, or it may be a bug. You know, this is new technology in terms of view groups in prepared, so it's possible that that's buggy behaviour. The other thing I've noticed that screws this up in a sense is if I OK out of this, in fact I won't OK out of this because that will give me errors. If I cancel out of this, something I've noticed and I can't explain, if I turn view groups off and then turn it on and reselect my, for example, center up triple display, the display always seems to default to a zoom factor of 1.21 for reasons that escape me. If you look up here, the top right of the screen, whenever I select that display, that view group, it defaults to a zoom factor of 1.21. Now in my mind that should default to 1.0, and I don't understand why it doesn't. So what I have to do is I have to zoom that out to 1.0 for it to be correct. So that now this is precisely what I set up in the view group creation screen. Now in practice that's not an issue, because I use ECCA to manage my views. It will do that. It will restore that zoom factor for me when I load this view group. But the point is, if I went in and edited this, so I clicked the allow zoom off to lock the zoom, it means my zoom is locked to 1.21, which is not what I want. Anyway. Now because we cancelled out that dialog, I have to recreate that new view group again. You have to be careful you don't click new or add on displays instead of view groups, by the way. And just to remind you, whatever we set up in this screen is the view that you will see when the zoom factor is set to 1.0. Now that's all you need to know really. Now those viewers who are really switched on might be wondering what the implication of changing the wide view aspect flag is. If I just go and find that, hopefully we can see that under graphics setup. Wide view aspect ratio is clicked on here. Remember this in FSX was an undocumented flag. We have access to it now, and that changes the behaviour of the zoom factor. I'm going to cancel out of that. All you need to know is that flag, if you're using view groups to manage your displays, the setting of that flag appears to be inconsequential. In fact, whether or not that's set to on or off, when you're using a view group to manage the view, the zoom behaves as if you had wide view aspect set to on. That's all I'm going to say about that. I might do another video on wide view aspect because people do get confused about what that does. So for now we have a new view group which we've just created. All we've done is give it a name. The first thing you need to know is there's a number of different ways of setting up these view groups, and this is a little bit confusing because there's much more on these dialogues than we actually need. You don't have to fill everything in. We'll see that as we go. I'm going to show you two ways to set this up. The first way I don't really advocate, but you might find it useful. It uses this thing called grid setup. Now you'll notice if we expand the thing over on the left here, there's a word grid setup that's greyed out. If we click add for grid setup, that's now no longer greyed out. We have an edit button. If we click edit for grid setup, the thing we're interested in is this thing at the top that says auto detect. It says no if we click yes. What that does is, if you remember when we looked at the setup in, I'll go and look at that, Windows or in the NVIDIA control panel, if we click up that auto button, it will come to the definition of this somewhere in underneath the hood in Windows, and it will construct a view group based on that layout, including the staggering of the monitors. And just to demonstrate that, if we go back, and we don't have to fill anything else in here. So if I OK out of that, and if we right click and we go to view groups and select our new video demo triple screen, we get something. Now again, the zoom factor, for some reason I don't understand, is initialized to something very large, 1.76. I'm going to zoom that out to about close to 1 at least. So there we are. Now that's given us something that looks kind of right. It's not perfect. We've got some strange. We've got a view that spans the monitors. The views do kind of match up. We do have this strange sort of twisting effect where the two outside views look a little bit canted downwards, and also you'll notice if I put, let's say, the windscreen wiper center screen on the center screen, we don't have bezel management, but that's okay. I mean, as a work in progress, that's pretty encouraging. But one downside of this is, you remember I've got 4 monitors set up. It's actually included that 4th monitor in the setup. Now you probably can't see that on the video. If I just try and scoot that camera on over so you can see that monitor. There's that 4th monitor down there, and you should see that, I mean, it has very cleverly incorporated that monitor into the view group, and it's correctly displaying an appropriate part of the virtual cockpit. But that's not what we want it to do. We don't want it to include that monitor in the view group. Now, so for that reason, I'm not going to use that feature to set up my view groups. But it's there. You know, if you have a simpler setup, you might want to experiment with that. I mean, the other problem with that, although we've got that working, you know, starting point for our view group setup, as far as I know, having used the grid setup method of creating that and using the auto detect, we can't go in and edit the details to tweak things like correcting the bezel management. And well, actually it looks like we maybe can correct the bezel management using this edge overlap, but that canting of the display, for example, at the edges, we can't seem to edit that. I think the only way you can edit that is to edit but behind the scenes, each of these view groups is defined by an XML file, and when we create the group in here, it creates that XML file behind the scenes. Now I imagine you can go in, if you understand what you're doing, and edit that file, but you don't seem to be able to set it up using the auto detect and then edit the details in the user interface. So back to the plot. So we're back to the point where we've just created the view group and given it a name and nothing else. What we're going to do to set it up manually is we're going to go to this area down here that says view, and currently that's got a grid or a table that's empty, and we're going to add 3 things to that table. One for each of the left, centre and right monitors. Let's do the centre one first. So if we click add, let's call it view 1. If we click this pencil to edit it, so now we get this screen where we can set the properties of that view. We're going to give it a name first. We're going to call it centre screen, we'll call it. So let's look at what we can set up for the centre screen. The first thing is the display ID. Now this is just a number that hooks it into one of those hardware displays that we looked at up over here. And all you need to know is your screens will, if you have a 3-screen display like this, they'll be numbered 1, 2, 3 from left to right. And so that's all that number has to be. Because we're working on the centre screen, we probably want to change that to 2. If you get these numbers wrong, it just means that the displays will be scrambled up, and you can just come back in and correct those numbers. Edge overlap, we're going to use this later to correct the bezel offsets, but for now we're just going to leave that alone. We've got the name. Now then, these 2 things at the bottom, we've got a thing called view frustum. If you don't know what frustum means, you can Google that. Just, you know, treat that as a synonym for view, if you like, or viewport, or window, or screen, doesn't matter. And we've got a thing called viewport. Now this is confusing. You do not have to fill in both of these sections. These are alternatives. Now you might be tempted, this screen is not very intuitive, you might be tempted to tinker with viewport, and you'll get into all sorts of strange effects. We're not going to bother with viewport at all. We're going to use this other thing. Can you collapse that? Yeah. The way we're going to set the screen up is we're going to edit this view frustum thing. I'm going to do that by clicking add and then clicking edit, and again we get some things we can edit, and we can edit 3 different things. The one we're interested in most immediately is this thing that says side angles. Now this is where we tell P3D how much of the virtual world we want to be displayed on our centre monitor, and we do that in terms of the angle of view. Now if you remember when we measured how much of the real world that centre monitor takes up, it's a 50-degree field of view, left to right, and if we want to, as we do, create something that gives us a more or less life-size view, we want P3D to project 50 degrees left to right of the virtual world onto that screen, and then everything will look pretty much one-to-one life-size on the screen. And so to do that we need to, using these left and right parameters, enter 50 degrees. Now you might think we would enter 0 and 50 for the left and right values, but actually the way this is set up, the origin, if you like, is the centre of the screen. So we have to give a left offset of minus 25 degrees. That defines where the left hand side of the screen of the view will be, and then we give it plus 25 to define where the right hand side of the view will be. Now that's not everything, because we need to define the top and the bottom as well. You'll remember we measured that as 28 degrees top to bottom, so we type in here 14 for the top and minus 14 for the bottom. Now just an aside here, if you hadn't measured that, you could actually calculate the vertical field of view by knowing the horizontal field of view. Now if you're going to do that, you need to make sure you do it correctly. You might be tempted to use the aspect ratio of the monitor to simply scale the the horizontal field of view, 50, by dividing it by the aspect ratio to give you the vertical field of view. Now that actually doesn't work, because those two values don't vary, those two angles don't vary in direct proportion. But for now we did measure those and we've just entered them directly. That is all we need to enter to give us a coherent view group that should display as a starting point. So if we just OK out of that, and it has indeed loaded that view group in. Of course it's only showing us one screen because that's all we've set up at the moment. Again, that annoyingly, that zoom has defaulted to 1.21, so that doesn't actually show us 50 degrees of the virtual world across our 50 degrees of real monitor, and the consequence of that is it looks more zoomed in, if you like, than it should do, and those gauges look bigger than life size. If I zoom it out to approximately 1, that's what we should see. So that looks fine. If we go back in and so if we go back into that centre screen, click the edit button, the view frustum, click the edit button, minus 25, 25, 14, minus 14. So that view looked approximately correct. Now this raises an interesting fact here, which is that the aspect ratio of the screen isn't locked, so you can enter different values, or inconsistent values if you like, for the vertical and horizontal fields of view, and we'll just do that as an experiment. If we were to, let's say, want to display a larger field of view in the vertical direction, let's say instead of 28 degrees we give it 40 degrees, so we'll put 20 up and minus 20 down, and we should predict a squashed, or at least a distorted display from that, and indeed that's what we seem to get. The gauges are squashed in the vertical direction because we're now displaying 40 degrees in the up and down direction, but still only 50 degrees across. Now there may be circumstances under which you want to do that, it might make sense, but it doesn't make sense for us at the moment. So if we go back in there and edit that, back to 14 up, 14, minus 14 down. Now having said all that stuff about calculating the vertical field of view correctly, if you were going to use that approach, scaling up from the horizontal field of view using the aspect ratio will give you approximately the right, it will put you in the right ballpark if you like for the vertical field of view. Then you can just tweak it by amending these values till your gauges look round. So that's another way to do it, by the seat of your pants if you like. Now in the same way we could set we could leave the vertical field of view at 28 degrees and put wider or narrower values in for the horizontal field of view, and then we'd get stretching in the other direction, but we're not going to do that. It's just the same principle. So that's our first display. So let's set up the next screen. We go to select the view group and go back to the views and click add, and view 2, if we edit that, and if we name that, what did we name the other one? Center screen. Left screen. So what do we need to set? Display ID, that is correctly set to 1. Remember, these are labelled 1, 2, 3 from left to right. Again, we're going to leave viewport alone. We're going to go to the view frustum area, click add, and then edit. And we do exactly the same here. We're going to, because this is the same sized and same dimension display, everything's the same up to a point. So we put -25 to define the left edge, we put +25 to define the right edge, we put +14 to define the top edge, -14 to define the bottom edge. Now we can OK out of that. If we do that, we've now got 2 windows displayed. The middle one is as it was before. The zoom again is set to 1.21. Don't know why that is. Now the difficulty is we've got an identical window displayed on each monitor. Now that isn't correct, so we need to do something about that. If we go back into the setup, now we left screen, edit, frustum, edit, and this is where we need to look at one of these other areas on the screen. And what we need to look at is the thing at the top that says offset PBH, that's pitch, bank and heading. And what that's really telling us, allowing us to do, is to swivel the camera. If you imagine that that view is defined by a camera looking out of the monitor as a window, we want to swivel it to the left, logically. And how far do we want to swivel it? Well, of course, the centre view that we've defined is logically 50 degrees wide. It's displaying 50 degrees of the virtual world. So we want to swivel the camera 50 degrees to the left and display the next 50 degrees of the virtual world. So we do that by going to the heading offset, and we set that to, because it's to the left, it's a negative value, so -50 degrees. And we should find, if we OK out of that, those views pretty much match up now, at least in terms of the horizontal angle. You can see when, if anybody knows why this zoom is anchored to 1.21, please let me know. But you can see that as we swivel around, the monitors are pretty much lined up and the view is continuous across them. Now, the other thing to note is the track IR is swiveling both of these views. If we did this in FSX, say, using setting up the windows manually, or even if we did that using something like Opus FSI to semi-manage those views, we can't use the track IR. The track IR would only swivel the main virtual cockpit view. So already we're way ahead of the game. Alright, now then, 2 things wrong with this view. The first thing is there's obviously a vertical discrepancy there. You know, if you look at the edges of the runway there, they don't line up vertically. So we've got to do something about, and that's because my screens, of course, are staggered. You know, the central screen is higher than the left screen. So we need to go back into View Group Management and fix that. We go to the left screen, Setup, Frustum, Setup. Again, we need to come back to these offsets and do something about that. Now then, my intuition tells me that I need to set something in here to change the vertical offset of that display. You know, logically that follows, because I mean, essentially what we've done is, in the physical world, the left-hand monitor is a little bit lower physically, so we just need to do something with this, I think, this Y parameter to compensate for that. And I think this is in actually meters or centimeters or something. If we set that to 0.025, I think that's 25 centimeters or something like that. Let's try that. And I think I've gone in the wrong. Whoop, turning the autopilot on there. I think I've gone in the wrong direction there. Let's go back and do that with a negative value. 0.025. Let's make it minus 0.025. Now I'm looking at the edge of the glare shield there. That pretty much lines up. Let's tweak that. Let's make that minus 0.0, let's say 3. Okay, out of that. And you see that glare shield now is continuous across the display. So that looks like a success, but if we pan up, that's kind of disastrous because the outside world doesn't seem to match up correctly. So we've done something wrong there. That's not the right way to fix that problem. To cut a long story short, and again, now I've established this through empirical tinkering. Really, I don't claim to fully understand this. The solution to that matching up problem is not to edit that offset X, Y, Z. I'm going to set that back to 0. And so, cutting to the chase, as they say, the solution to this problem is to set the pitch, this pitch angle of the leftmost view, to pitch the view up. And that's how we can match them up. And I'm going to, just from memory, I happen to know that a suitable angle to pitch up is 3¼ degrees is about the best match we can get. So if we do that, we have a good match. You can see the edges of the runway line up, the horizon lines up, and the glare shield lines up. Now we've still got a slight discrepancy because of the bezel management, don't forget. And if we tilt the horizon, you see that doesn't line up properly the further we tilt. So we're going to fix that now. So we go back into View, Group Management, Demo, Triple Screen. Okay, to handle the bezel management, we're going to go back to the center screen. If we go to the center screen, edit that, and we're going to use this edge overlap. We have some values in here. These values are percentages of the total screen field of view, if you like. So what do I mean by that? Well, the field of view left to right is 50 degrees. What we need to know is, as a percentage of that, how wide the bezel is at the left and how wide the bezel is at the right. Now the simplest way to do this is to measure the physical dimensions of the viewable area of the monitor in the horizontal direction, which is pretty much 70 centimeters in my case, and then physically measure the bezel width. And the bezel width is pretty much 1 centimeter. So in other words, the bezel width is 1/70th of the width of the screen, which as a fraction is 0.014 or 1.4%. Now we need to be slightly cautious here. If we use that 1.4% to scale up the angle of view, that's only going to give us an approximate value. Again, that angle of view doesn't vary linearly in proportion to the physical dimensions of the monitor. Now, if you don't understand that, never mind. We can do this just empirically. Okay, so we've calculated our approximate value for the bezel compensation, and basically we want to enter that percentage minus as a negative number for both the left and right edges of the screen. Oops. And because we've got bezel on the centre and on the left screen, we need to do it on the left screen as well. Minus 1.4 minus 1.4, and we should find our bezels are now pretty much working correctly. So you can see across the windscreen wiper there and across the glare shield, that's working, across the door pillar, and the horizon works pretty well. In fact, we can tweak that. If we go in, I've established through just tinkering with this that a better value is actually minus 1.25. You okay out of that? So that's pretty much close to perfect as we're going to get with the bezel management, but everything seems to line up pretty well. I'll say one more thing about bezel management in a second, but first thing we've got to do is we're going to set up the right hand screen, which is exactly analogous to setting up the left hand screen. We go to video, so I'll just do all this in one hit, video demo, triple screen. We're going to come back out of that and set the edge overlap to be minus 1.25. In fact, what I'll do is I'll leave that edge overlap at 0, so what we should have is a bezel management that's working correctly on the leftmost intersection of screens, and the one that's not working correctly on the rightmost intersection. So if we just OK out of that. Okay, that was an error. I forgot to set one of the parameters for that new rightmost screen. I left the display ID at 1, it should be 3. We OK out of that. So we've got the display which is looking pretty much correct. Bezel management is working on the left to center screen, but if we look at the bezel management on the center to right screen, you can see there's a discrepancy there. That's not working properly. So you can see that those bezels do need to be set up independently, and the reason I'm drawing attention to that is there's actually two ways we can do that. The straightforward way is to go into this rightmost screen and edit these values to be the same as they were on the leftmost screen. But actually, because we've only got 3 screens, we could do the bezel compensation entirely by accounting for the whole width of the bezel on the center screen. So without going into this in too much detail, if we were to set up the center screen, instead of 1.25%, if we set that to 3%, that will effectively account for a 2 centimeter bezel in one hit at each side, and it means we don't have to do anything with the left or right screen. I hope that makes sense, but let's just try that out. If I put that to minus 1.25, 2.5 rather, not 3, yeah. If I put minus 2.5, minus 2.5, and then go to the left screen and just put that back to 0, and again on the right screen that's 0, we should find that bezel management now works correctly on both sides. So you can see things line up on the left and also on the right. And that's pretty much it. We have our view group set up, we have proper bezel compensation, we have the staggering of the screens accounted for, and we're fully track IR compatible. Now one last thing I will say, if we go back into that view group management, if I select the view group, there's a parameter we didn't look at, which if you look right towards the bottom of this, the view group shape. Now this has an option for selecting cylindrical, spherical or flat. Now what this allows you to do is essentially choose the projection algorithm to avoid having distortion out at the extremes of the display. Now actually, regardless of which of these algorithms you choose, we're not going to see distortion out at the extremes of the display when we're using sufficiently narrow displays, and the displays we're using are only 50 degrees wide, and that is considered narrow. If we were using displays, like we might be using projectors to project a 100 degree or more field of view, that's when we start to get, this is like when you use your single window triple wide display using NVIDIA Surround or iFinity. That's the circumstance under which choosing a different projection algorithm would make a difference. So really it doesn't matter. This defaults to cylindrical. I would suggest that it's probably best to choose flat here. My intuition tells me that a cylindrical or spherical projection algorithm may actually take more calculation to produce. So it may be that choosing flat gives you a benefit in terms of calculation. So I would suggest that you select that to flat. Now the problem is for me at the moment, if I select that to flat, for some reason my view is no longer zoomable. Now I don't really know why that is, but you can experiment with that yourself and figure it out. So that's hopefully not too confused explanation of how to set up your view groups in Prepared version 4.2, and it should serve you well, at least to get you started. I don't have a full understanding, as I've said as we've gone along, of all those parameters in there, but I've been able to set up the view without too much trouble to do pretty much what I need, and it's definitely flyable. And in particular, it's allowed me to do this staggered screen layout, to not have I've got an absurdly wide display without distortion at the edges. This is 150 degrees more or less. But what's most interesting to me is it's opened up the possibility of an alternative, or a number of different alternative display layouts, because the monitors don't all have to be the same size or even the same resolution. They can be different orientations. And a couple of things I've thought about doing, if you remember back to my experiments with the side views, which were driven by a different computer, slave computer, in that experiment, but using this method and exactly the same setup, I could drive these three displays using two of them as side views in a portrait orientation, which pretty much gives me what I had before. The only difference is the central portion will be supplied by this relatively small, in terms of width, 32-inch display. But what I'm thinking of doing is buying a bigger TV for the centre. Maybe here now we have to compromise again, because I could get a bigger 1080p screen, perhaps a 42-inch, or perhaps larger, and that would give me a good width, but of course the resolution would be lower. The alternative is obviously at some point to go to a 4K monitor then and get something like a 50-inch, 55-inch. But I think in terms of performance that's going to be optimistic at the moment, so we're not going to do that. So that's it. Can't think of anything else that you need to know at the moment. I'll keep tinkering with this, and perhaps I'll do an update at some point if I discover anything new that I can add to what I've said. But for now that works for me, and maybe it'll be helpful for you too.